Alright, model column drops. In order to increase the punching resistance, drop panels can be inserted with the concrete slabs at points where they are supported by columns. Column drops are slab thickening that can be above the slab, below the slab, or both. Column drop is rectangular in plan and is aligned to the column axes. The extent of the drop is limited to the extent of the slab boundary. The cutback drop shape may not be rectangular. How do I create a column drop? In order to find a slab drop, you must have already defined with a concrete slab to which it applies to create the cut drop. One, click the model, then from the second slab drop list, couple on the drop. The column drop properties are displayed with the property windows where you can enter the geometry of the drop. Drop is always positioned centrally over the supporting column. Clicking the existing column connected with the concrete slab panel will create single drop panel. Box around multiple columns to create series of drop. For the drop panel to be inserted correctly, it is important that the construction level dialog is setting out the type of slab in the question of SSL and not top of steel. Splitting joint and slab mats. Existing slab panels can be subdivided into smaller panels using slab split command. Similarly, they are merged into larger panels using slab join command. The slab split and slab join commands are only accessible when the 2D view is activated. How do I split a slab? Click model slab split or foundation mat split as appropriate. However, the cursor over the slab edge where you want to split the start. The points you have defined with the cut line can be outside of the boundary of the slabs being split. You don't have to be on the slab edges. They don't have to be on the slab edges. You can use the grid points or other points of interest. Suggested split points aligned with the edge or highlighted selected point may be being indicated by a red dot. Clicking the point indicated the move the cursor further along the edge to identify other points which could be split. However, the cursor over another slab edge, either the same or another panel, entering the clicking at the point required, continuing click subsequent points to continue splitting, or double click to complete the split. Any slab panels entirely crossed by the cutting line or split along it. How do I join slabs? Click the model slab join foundation mat join as appropriate. Pick the fit for slab panels you wish to join. The master panel. Pick the next slab panel, and the two panels are joined to create a new panel which adopts the property of the master panel. The panels are to be joined must share a common edge. Pick additional panels that are required to add master panel. Press escape when to complete slab steps. A step of the model with the Tekla is structural. The design is a panel to which the slab depth override or vertical offset is applied. Steps can therefore be located anywhere in the slab of the panel. Can create a slab split and slab join commands are likely to prove useful for their creation. When additional data needed to allow the panel to be stepped up or stepped down is override slab depth, check the depth, and vertical offset, vertical positive vertical raise panel surface, negative vertical drops it. Vertical offsets are not structurally significant. They have no effect on the analyst mesh position. Relative to the top of the slab solver in the solver model, the mesh properties would, however, the reflecting change the slab thickness. How do I modify the shape and the size of the panel? You can modify a panel in both 2D and 3D views either by moving the nodes or its edges. How do I modify a panel by moving the node? A panel can be modified by moving the nodes of the corner midpoints of the panel edges as follows. Select the panel you want to modify, click the node in selection, select it, and then select any of the new node SI4. Move the cursor over the existing construction point with the intersection, and then click to reposition the node. Alright, the new node position must be the same plane as the panel. When the panel nodes are moved, note that when the node of the midpoint over the edge is moved, it becomes a new corner node, causing two new midpoints nodes to move automatically created. When the corner node is moved directly over the adjacent corner node, the original corner node is deleted. How do I modify a panel by moving the edge? A panel can be modified by moving the edge as follows. Select the panel you want to modify, click the edge away from the nodes and to select it. 3. Move the mouse over the existing construction point intersection and then click to reposition the edge of the passive through the point selected. The new edge position must be in the same plane as the panel. How to apply curve edge to existing slab items? Select the slab items you want to modify. To apply the same degree of curvature to all the slab edges, locate all edge property, uncheck linear, enter the curvature required chord offset, specify the position, positive value to the curve inwards, negative value to curve outwards. To apply the curvature, specifically the edge, locate the edge of the property 1, 2, 3, etc. for the required edge, uncheck linear, enter for the curvature required for the chord offset, specify the positive value to curve inwards, negative value to curve outwards. The slab panel is redrawn with the specified curvature. How do I delete an entire slab from the model? Open the slab branch how do I delete an entire slab from my model? Open the slab branch from the structure tree. Right click on the name of the slab you want to delete. Click delete slab for the context menu, which appears textual or structural. Deletes the entire slab from your model. Timber member modeling. Timber sections can be modeled with the inner line of the Tekla structural design, but they are not designed in working Euro codes. Timber section can be exported with the Tekla TEDs for design. Tekla TEDs is a separate purchasable purchasable product. Modeling timber columns. How do I create a singular timber column in a 2D view? Ensure that you define the custom instruction level between the column will run with the grid points between which it will lie. Click model timber column. The column will adapt the properties currently displayed. Timber column's properties set. Check the base level and the top level shown in the property set are correct and adjust if they are. Check the other properties shown in the property set of as are also correct. Again, adjust if necessary. Click the point 6. Click the point where the column is to be placed. Add and how do I create a series of timber columns in 2D view? Ensure that you define the construction level between the column will run and the grid points between which it will lie. Click model timber column. The column adapts to the property currently displayed with the timber column property set. Check with the base level, the top level shown in the property set are correct and adjust as necessary. 5. Check with the other property shown in the property set but are also correct. Again, adjust as necessary. 6. Move the cursor over to 1 over the corner imaginary boxes and comes to the grid intersection points you want to create columns. 7. Click and hold the left mouse button. 8. Drag the diametrically opposite corner of the box. You'll see a rubber rectangular on the screen with the file of the mouse movement to help you check the area in which you are creating. 9. Once the rectangle and comes to the grid intersection points at which you want to create the columns, release the mouse button. How do I create a single timber column in a frame or structure view? In order to define the column in a frame or structure view, you must have already defined the construction level between the column will run in grid points between which it will lie. To create the column, click the model and timber column. The column will adopt property with the currently displayed timber column property set. 3. Check that the properties shown in the property set are also correct. Adjust if necessary. 4. Click at the point where the column is to start. 5. Click the point where the column is to end. Tekla structure creates designer creates the column between the 2 points. How to align a column in a specific angle grid line. There are options provided with specifying alignment with the new column achieved by the setting of the rotation property as follows. 0, 90, 180, and 90 aligns the column in global axes. Angle aligns the column to exact rotation angle you specify, and define aligns the angle to a grid line you select. How to create an inclined column. An inclined column can be created with the frame and structural view. In order to define the column, you must have defined the construction level between which the column will run, grid points between which it will lie. Click the model timber column. Check that the timber column properties are shown in the property windows are correct. With adjust necessary. Click with the point where the column is to start. Click with the point where the column is to end. And the Tekla structural designer creates the column between these 2 points. How do I create a crank column? A crank column can only be created with the frame and structural view. But in order to define the column, to define the construction level between which the column will run, grid points which will lie. 1. Click the model timber column. Check that the timber column properties of the property windows are correct. Adjust as necessary. Click with the point where the column is to start. Press and hold the control key keyboard. Click the next node over the crank column. 5. Repeat step 3 until the define with a new penultimate node over the crank column. Release the control key. Click the point where the column is to end. How to modify position of single column stack. Column stack position can be modified either in frame or structural view and scene content. Ensure that the grid construction for lines box is checked. Select the column in which stacks is moved. Column is highlighted in one color of the column and the end node of the middle node is another. Select one end nodes of the column to be moved. Ensure that the node over the highlighted select any tooltip when selecting a with the one member is connected with the node. 4. Click the grid construction point. Redefine column stack end node position. The entire column is reached on selected node move to the new position. Select the next end node with the entry of the node is highlighted. Select any tooltip when selecting opposed to one of the members connecting the node. 6. Click at the grid construction point to redefine the end node position. The column is redrawn once more with the selected node move to the new position. How to modify the position of the entire column? Simply use the move command located with the edit ribbon and modeling timber beams. How to create a single span timber beam? Click model timber beam. The beam will adopt the properties of the currently displayed with the timber beam property set with a review of the property set adjusted when necessary. 3. Click the beam where to start. Point 1. If you're using a point along a member, then click the member first to see the points enter the click. If you want to see the type of the distance of the point with the chart of the member, click where the beam is to end. If the prompted with a pick another point, point 3, you will do with the continuous being selected beam property set. In order to create a single span beam, simply click once again in point 2, press enter key. How to create a single span of timber beams. In order to create a beam using method of a floor construction level, there must already be determined the columns between the beams will run. You must also see the 2D view of the floor construction level to use the option. Click model and timber beam. The beams adopt for the property for the currently displayed with the timber beam of the property set with a review of the property just as necessary. With the move of the cursor to one corner over the imaginary box and complete with the columns between them in which you want to create beams. Click and hold the left button, drag the diametrically opposite corner of the box. You'll see with the rubber rectangle stream of the file with the mouse movement that helps you check the area in which you are creating. 6. Once the rubber rectangle and comes with the columns between them in which you want to beams creating, release the mouse button. Beams are created between the adjacent pairs and columns and the areas are select. How do I create a continuous timber beam? Click model timber beam. The beams are edible adopt for the property currently displayed with the timber beam property set. Ensure the continuous option is selected with adjusted if any of the details is necessary. Click the beam and where is to start. If you're using a point along the member, click the member first to see if the points enter the click and where you want to type the distance of a point and start of the member. 4. Click the next node of the continuous beam. If you're using a point along the beam and a member, then click the beam and the member first to see its points, then click each of the point where you want to use. Type of the distance and point over the start of the beam. Repeat step 4 until the defined ultimate node over the continuous beam. Click 6. Click where the beam is to end. 7. You are now prompted to pick another point. Simply click once again on the same point. Press enter key to create the continuous beam. You cannot define continuous beams which are curved either horizontally or vertically. How do I create a curved timber beam? Click model and timber beam. The beam will adopt the property currently displayed. The timber beam's property to set with ensure the linearity is set to the curve major if the curve is vertical or curve minor if the curve is horizontal. Enter appropriate chord height values specified by the define on the curve. You can control the direction of the horizontal curve beam curves when you place the beam selected with the start point with the end point. The beams always curve such that if you were to look along the theoretical line of the start point with the end point, then the curve of the beam will always lie on the right of the line. Vertical curved beams with a negative chord height value used to reverse the curve direction. Adjust for the detail of the property set when necessary. 4. Click with the beam to start point 1. If using point along with the member, then click the member first to see that its point with either click the point we want to use with the type of the distance for the point in the start member. 5. Click the beam where the beam is to end. Point 2. When defining beam with a curve vertical with the 2D view floor construction level, the vertical projection of the beam is out of the plane floor construction level that you're using. In this case, you will not see the beam graphically displayed. You will need to change the 3D view floor construction level of the entire structure in order to see horizontally curved beams. Always take the chord height defined in the property set, but they do not curve automatically to fit with the curved grid line that may have been defined. How do we modify a position of the beam? Modify the individual beam position, both 2D and 3D views. The selective of the beam and the move of the beam is highlighted and color the beam and the end nodes and the middle node is another. Now select the beam and the end node that is remove it. Ensure the node that's highlighted. Select any tooltip selecting it as opposed to one of the members connecting within the node. Click the grading construction point to redefine the beam and the end node position. The beam and the redraw and expanding with the new end position. Model timber braces. Modeling timber braces. Tekla structural designer allows you to define braces to provide lateral stability to you for the structure. Alternately, specify the rigid frame to achieve the same effect. You can also use both methods with single structure should it be necessary. How do I create a single timber brace? Model timber braces. The brace adopt the property currently displayed with the timber braces property set. Review the property set adjusted necessary. Click the brace to start point 1. If you're using a point along the member, click the member first to see the points, then click the point you want to use. Type of the distance of the point with the start member. 4. Click the brace to end point 2. A and V braces should be molding should be special tools which can be found with a timber brace with the drop lift for the timber section of the model tab. Although it's also possible to model the exact brace arrangement with the individual elements created using simple timber brace commands. Important note that while the equivalent horizontal forces calculated with the model using A and V brace tools are correct, this is not the case of the A and V braces built up with the individual brace members. In the later cases, elements of the vertical loads that are supportive of the bracing system loss are not included in the equivalent horizontal forces calculation. Result calculated with the equivalent horizontal forces are not correct. How do we create a KVA brace? The model then 1. Click model, then from timber brace drop down, select the pattern XK or VA. The braces adopt the property for the currently displayed in timber brace property set with a review of the property adjustments necessary to identify with the bottom corner of the beta B brace point 1. Click and identify with the bottom corner of the beta B brace point 2. Click and identify with the top corner of the beta B brace point 3. You'll see with the rubber rectangular screen with the file with the mouse move to help you check if the orientation is correct. 6. Click and identify the opposite of the top corner to be brace 3.4, the brace pattern is created with the area that you've selected. How do we modify a position of the brace? You modify the individual position in both 2D. You can modify the individual brace position in both 2D and 3D views. Select the brace to be moved if the brace is highlighted in one corner, the brace ends in another. Note 2. Now select the end of the node that is to be moved and ensure the node is highlighted with the select any tooltip selecting opposed to one of the members connecting within the node. 3. Click with the grade construction point with the redefine of the brace end node position. The brace is redrawn, spanning with a new end position, modeling timber trusses. Trusses are particular in arrangements. Member of the Tekla structural design calculates automatically for you. Once you have created the truss, you can copy throughout with your model if necessary. You can pick up the truss and move it to the location you require. How to use the timber truss wizard? Click model timber truss. Choose the truss shape with the list of the chain truss patterns. 3. Click the truss start point, and if you're using the point of the member, then click the member first with the point with it, and click at the point with which you want to use the type of the distance of the point with the chart of the member. 4. Click the truss endpoint with the click next, and specify the truss arrangement parameters. Click next. Specify the truss details, then click finish. How do I use the timber space truss wizard? Click model timber truss drop down list space from the drop list. Check either linear or planar truss type, then specify the alignment and number of base, then click next. In the 2D and 3D view, click the truss location from the linear truss, click the chart and endpoints from planar truss, click the 4 corners, specify the height of it, then click next. Define either the straight or curved truss geometry, then click finish. Specify the truss alignment parameters, then click next. Specify the truss details, then click finish. How to identify the freeform timber truss? Freeform timber truss can be created by placing series of the truss members in the shape required. Opening 2D frame with the trusses created with the note the freeform of the trusses can be created within 3D view and 2D level view. Click model timber truss drop down list. Freeform over the drop down list. Click where the first truss member is to start. Click where the first truss member is to end. Continue the same way and to paste each truss member until the truss geometry is complete. Press escape to finish. How do I edit the geometry? Existing timber truss over the cursor over the truss. The edit becomes highlighted. Right click, select edit from the drop down menu. Truss wizard is displayed. Edit the properties is required. Then click OK. How do I edit section size, material grade, section orientations in existing timber truss? However, the cursor over the truss, the edit becomes highlighted. Left click the truss display. Edit the timber truss properties. The review of the properties set with adjusting necessary. Then click OK. Panel modeling. Topics have with related specifying the model each of the different panel types found with the model tab. Modeling roofing panels. Roofs are medium V with the width of the load with a placed on sloping panel plane with a decomposed with the back to the supporting structure of the area loads of roof can either vertically or normal to the roof plane. How do I create a roof panel? In order to define a roof panel, you must have already defined the grid points to which the define the outline. You must identify these in order to create the roof panel. Click model roof panel. Click with the grid point with the panel to start. Click the point with identify with the next vertex of the panel. Continue with the grid point for the define perimeter of the panel until you reach the final point. You must have 2 points. Either double click with the final point, single click with the first final point, and then click the first point with the panel again. 5. Tekla structural design will create a roof panel between the points that you've identified. You cannot define a roof panel that does not lie in a single plane. If the points you define do not so lie, then the Tekla structural designer will fail the panel during validation. How do I edit the property of the roof panel? You can edit roof panel property within both 2D and 3D views. However, the cursor over the panel, the edge of it becomes highlighted to the left, click and then select the roof panel property to display with the property windows required with the property point you added further the roof panel's current selection by holding the control key while clicking on each subsequent panels. Edit this property that is required. Any changes are automatically applied to all of the selected panels. Modeling wall panels. Wall panels are also referred to as wind walls or medium viva, which are loads calculated with a simple wind loading generator wind wizard or applied to your structure. Walled panels do not introduce structural strength stiffness of any kind of your structure. If you wish to introduce a wall that resists gravity lateral loads, you may model these by defining the concrete walls. How do I create a wall panel? In order to define the wall panel, you must have already defined the grid points which define the panel vertexes identified with these. In order to create the wall panel, click model wall panel. Click the grid point with the point is to start. Click the point with identify with the next vertex of the panel. Click on and then 4. Continue to click on the grid points to define the perimeter of your panel until you reach the final point. You may have 2 options: either double click the first final point or single click the final point and then click the first point of the panel again. The minimum number of grid points to define a wall panel is 3. Tekla structural design will create the wall panel between the points that you had identified. You're going to define a wall panel which does not lie in a single plane. If the points you define are not so lie, the Tekla structure will will fail panel during validation. How do I edit properties with the wall panel? You can edit wall panel properties with the 2D and 3D views. However, the cursor over the panel be edited to become highlighted. Left click and select it. Select the wall panel properties panel with the property window if required. Then point with the further wall panels to current selection by holding Control key while clicking on each subsequent panel. Editing the properties as required. Each change will be automatically applied to all of the selected panels. How do we create a wall panel with a carpet? Wall panel with a carpet should be modeled within two parts. The ordinary wall panel is created up with the roof panel. The second wall panel is created above the roof level when marked with a carpet. Modeling ways in this way ensure that the wind analysis correctly and accounts for the carpet. Create two parts of the wall panel. Open the frame view of the wall with it being created. Create the wall panel below the roof level, the ordinary wall panel. Create the wall panel above the roof level as an ordinary wall panel. Construction level may be required to define the top level of the parapet. To mark the upper wall panel as a parapet, to ensure the existing wall panels are currently selected, press Escape. Hover the cursor over the panel. The edge of it becomes highlighted. Left click Select. Then selected wall panel property to display with the property windows. If the property windows, select with the checkbox indicate the panel with the parapet wall. How do I reverse a wall panel? Wall panels are generally created so that they have the outer faces automatically pointing outwards. For certainly complex modeling building geometries, it may occasionally be necessary to alter the inner and outer face of the panel should be necessary to achieve using the reverse option. Click Model Reverse, edit the group and the wall panel to be reversed. Selected panel changes color indicating that it has been reversed. Support analysis element bearing wall model. Modeling supports allow the constraint points of the structural vertical and rotational. You can also support model connection with existing structures that you do not need to incorporate with the current model. The fixity provided with existing support that can be changed with a modifying support property tag with the created single support. Supports can be placed with existing grid points created with the support. Click Model Support. With the support will adopt with the property with the currently displayed support property to review the property set adjust as necessary. 3. Click with the grid point where you want to create the support. How do I create a rotated support with 3 grid points? A local coordinate system and apply with the support along the X and Y axis to be rotated along the global Z. Click click the model support before placing the support. Ensure the 3 grid points option is selected in the support properties. Click with the grid point where you want to create the support with the define the support with the direction. Click by a second point to define the X direction. Click the third point to define the Y direction. Note the Z direction cannot be changed. How do I create a spring support? Linear and nonlinear supports can both be created in similar fashion. Click model and support before placing the support. Edit the properties as follows. Ensure the direction of the spring is required to act with a degree of the freedom and set to free. Ensure stiffness properties are described in the support properties. Click with the grid point where you want to create the support. How do I edit the properties of support? You can edit support properties in the 2D, 3D view that I have with the cursor over the support. Edit will become highlighted. Left click and select. Then the selected support properties display with the property windows. If required over the point, add further requirements for the current selection by holding the Control key while clicking on each of the subsequent supports. Edit with the properties that are required. Any change will automatically apply to all of the selected supports. Modeling analysis element. How to create an analysis element. Click the model element and it looks like a line. The member will adopt the property currently displayed element properties. Review the property set and adjust as necessary. 3. Click where the member is to start point 1. If you're using a point along the member, then click the member first over the point that enter the click point where you want to see the type of the distance of the point and start member. 4. Click where the member is to end point 2. How do I modify the position in the analyst element? You're modifying an individual analyst element position, both 2D and 3D views. Select element to be moved with the element highlighted in one color, the end nodes in middle node in another. Now select the element and node that is to be moved and ensure the node is highlighted. Select any tooltip, selecting in the pose of the other member element connecting to the node. Click the grade construction point, redefine the element end node position, the analyst element redrawn spanning the new end position. Model bearing walls. Bearing wall overview. Bearing walls are used to provide resistant vertical compressive loads that are not lateral load support certain other member types. Unreinforced masonry walls, for example, could be modeling of the bearing walls. Bearing walls can be created over several stories heights. Single walls created with a uniform thickness between the base and the top level. The location over the wall determine the alignment specified with the bearing wall with the properties insertion point picked. Bearing walls do not perform the same function of the wall panel, but they do not act with the medium for the view with the load calculated with the wind wizard will get applied with the structure. Therefore, in order for the wind wizard to apply, you should create a wall panel with the same function physical location of the bearing walls. How do I create a bearing wall in 2D view? Ensure that you define the construction levels between the wall and will run with the grid points in which it would lie. Click the model bearing wall. The wall will adapt with the property bearing wall property to display within the property windows. Show the base level, the top level shown with the property show that are correct and with adjust as necessary. Check the thickness of the other property shown with the property set are also correct and adjust as necessary. Click where the wall is to start point 1. Click where the wall is to end point 2. Tekla structural design create the wall between the points clicked on. How do I create a bearing wall in the frame structure view? In order to define the wall frame in the structure view, you must have already defined the construction level between which the wall will run and grid points between which it will lie. To create the wall, click the model bearing wall of the wall at adapt with the property bearing wall property display in the property windows. Check with the thickness. The other properties shown on the property set are also correct and just as necessary. 4. Click the first corner of the wall. Either click at the opposite corner of the wall to create a single click and adjust the adjacent but then opposite corner of the wall to create the using 2 clicks. Tekla structural design creates a wall between points clicked on. Submodels. Some structures are required to subdivide with the horizontal planes between levels in order to create submodels. Each submodel can be used to control the slab mesh parameters at levels within it. Until further submodels have been introduced, the structure initially to be treated as a single submodel with the same mesh parameters applied with globally to all mesh slabs. Additionally, submodels created with the automatically for every level specified with the flooring and the construction level dialog with either grillage chase down or FE chase down with an analysis of performance that can be defined manually with the submodels dialog box. Slab mesh parameters specified with the submodel used in analysis. Requires slab to be mesh load decomposition building analysis, mesh floors, and FE chase down analysis. Then both grillage and FE chase down with analysis perform one submodel at a time, and the topmost submodel will be analyzed first with the support reactions applied with the loads for analyzed submodel below. The sequence continues until the submodel down with the foundation level that has been analyzed for both of the analyzing types of the if required the default support conditions applied with the submodel characteristic definition. Following definitions are applied. Submodel definitions are applied. Submodel part with a 3D model between the two horizontal and submodel divide planes. Each submodel contains all of the members of the entire part between the two horizontal planes. For those common walls and braces served by a divided plane with the stacks of the brace, the length, and above of the top plane with are included in submodel the stack of the brace length below lower plane. Submodel divided planes are horizontal planes that can be positioned, added, deleted, or moved. In the 3D structure, the submodel divided planes are not notational infinite, but they are only permitted to cut through the structure where there is only a server, column stack, wall stack, steel braces. Submodel supports are artificial supports are defined in the system of the column and wall stack end of the braces that pass through the divided planes. Structural supports of 3D structure are defined by the user. Column and wall stack span lengths of the column and wall. The volume of the submodel with 3D space that exists between the two adjacent submodel divided planes. Basic rules of submodels. There are a number of basic rules to assist understanding of the submodel. All submodels will be considered from the complete structure. Only some of the column stacks, some of the wall stacks, some of the braces, those split with the submodel divided planes are in more than one submodel. So every model of the 3D model is at least in one submodel. The submodel can contain a member already in the submodel list. The member is a column wall brace divided by a submodel divided plane. A submodel must contain at least one member beam, one truss member, and one slab panel. Submodel dialog box. Dialog box success in the structural tree is you split the structure into the continuous series of submodels working with the top of the building into and including the foundations. So your sub-level level is active, OK, cancel, enter below, and delete, auto, generate, and generate. Fields, level. Initially, before any of the analysis had been performed, only two levels are displayed. One set with a distance of 2 meters above the construction level. The second with the same with the distance below the base level. They cannot be changed at this point with a single submodel compromising the whole structure activity. The active levels of the divided structure from the submodels over the top and bottom level must always remain active. They must always be at least one submodel. Once intermediate levels have been inserted, you choose the inactive of them, and if required, in which case submodels immediately above the submodel with immediately below the level of the question emerge from the single submodel. Or generate. If you have an adjustment with the cutting plane level, any of the inactive must also clear the auto generate, otherwise change that have been made for the next time submodes are generated. Buttons. Insert above, click and the insert above button clicks the button to insert to the next level between the selected level of one above. The default of being exactly halfway between them but can be edited with the manually provided remains to be between the two. Insert below, click the button is to insert the new level between the selected level level and the one below. In the default of and being exactly halfway between them, that can be edited manually, provided with the remains between the two. Deletes the selected level. Generate the button. This button can optionally be used to auto-generate a default submodel for every level of the specified level floor and construction level of the dialog. Make sure to do this for the review of the submodel prior to the first run of the analysis. It is optional. The default submodel will be generated for the automatically when you run the analysis, provided the auto-generated when the dialog box is checked. The generated button can also be used to revert back to the default submodels at any time. If you made an adjustment with a cutting plane level made any activity, you should avoid clicking and generated with the button. Even the auto generator box is cleared also, as you will lose edits of the you have made. Working with submodels. How do I open a submodel dialog box? To open the structure sheet, double click with the submodels. To open it with a ribbon, click the model submodels. How do I create a submodel? If the submodel dialog box generate automatically creates the submodel levels, alternatively insert and above and insert below to manually create them. For each new level necessary, modify with the height above the base level of the level field. How do I delete a submodel? In submodel's dialog box, over the submodel level and remove it, then click delete, click OK to choose the close of the dialog box. How do I open a 3D view of the existing submodel in Project Workspace, expand submodels, brand structure T, then double click with the right submodel, right click on and open it with a particular type, substructures. If required, to choose the place of collection of the elements named substructures, this can be provided useful large model for the individual substructure that can be differentiated by the color worked or separate substructure views. Purpose of the substructure is primarily simplified with the modeling visualization. Substructures themselves are never analyzed. They are distinct from, not to be confused with submodel substructure characteristics. The basic feature of substructures are elements can exist more than one substructure. Not every element has to be in the substructure. Deleting substructure does not delete the elements within. Working with substructures. How to create a new substructure on the status bar. Click Review, View. Click Review Substructures. In Review Update dialog, the property windows update selected. Update substructure dialog box next new. In the name dialog box, enter the name of the substructure. Choose the color of the substructure. In the review, click the box around the members to include the substructure. Change the selection mode with only remove and add or remove if you need to remove the members from the substructure. To add and remove the existing elements, existing substructure, on the status bar, click Review. View. Click Review Substructures. In the Review Update dialog box, property windows update selected. Update substructures dialog box selected with the substructure to edit. In selection mode dialog box, choose the edit operations required. In the Review View, click on the box around the members to be edited. How do I review all the existing substructures on the status bar? Review View. Click Review and Substructures. Review Update dialog box, property windows select Review all. Each substructure is shown with a different color in the display. How do I open a 3D view of the existing substructure from the project workspace? Expand the substructure branch of the structure tree, then double-click the substructure, or right-click on the open view of the particular type. Measure commands. How do I measure distances? To measure a distance between 2 points on the model, click Model Measure. The node, pick a node to define the start position. Pick a second node to measure to. Distance between the nodes are displayed on the current view. To clear of the measurement, press Escape. How to measure angles? You can only measure angles in 2D views. So you need to click on the model and measure angle. Click the node to define the arc center and select the node to define the start position. Third node to define the end position. The clockwise angle between the start and end position is displayed on the current view. To click the measurement, press Escape. What are the points I click? What are the points I click to create a member? The beams, column, brace, analyst, elements, etc. collectively referred to as members. In order to define these, it may define the points between them where they lie. The points you click in the combination of the grading construction point with the pick of the grading construction point lies part of the long end of the existing member. Simply move the cursor along the member to the point required with the dialog box. CP. The CP will find the grade construction point at the end of the member. So, and it shows your X and Y values. Enters when it finds grade construction point part way along a member. And to specify use of one of the other points, best down on the cursor key with the correct point and then highlighted and shown above the dialog box. Start points, point and note. Start standard points for the elements which have it already defined. Position cursor for the existing element within standard points automatically appear along it. These are a quarter, a third, half, 2/3, and 3/4 of the span of the element. Special points for the elements which have already defined. Special points created for the automatically allow when you create with a member which is perpendicular to the first element that you pick, perpendicular to the second element that you pick, perpendicular to the x-axis. whose ends lie at the same distance of the x from the origin of the model, perpendicular y-axis of those whose ends lines over the y-distance origin of the model, having picked for the first point end of the existing element to use the special point's position of the cursor over the second existing element of the dotted line to indicate the perpendicular standpoint location. A point specified by the distance wherever the values enter directly along with the member. To pick a point specific distance, simply moving the cursor along with the element and point. Required click to specify and point to, and click along F2 to edit. You can zoom in to achieve the finer accuracy moving along the element. Alternately, pressing F2 can type the exact distance directly, then pressing Enter to use it. The option creates the graded intersection point over the top of the tap of the element. If you want to use the point again, then you pick each for the graded intersection point. Please note that the opposite option does not create a new point along with the element. Model validation. Your structure should be validated before analyze. Design validation checks elements for the structure with a wide range condition that any of the conditions satisfied by the Tekla structural design tells you. Validation is performed automatically whenever the design process is initiated with a design ribbon, but it can be run manually at any time. The check that performed during validation can be set with the validation settings. At the end of validation, two types of messages can be displayed with the project workspace status tree. Or you have an error message preventing the analyst continuing until the appropriate corrective action is taken. Warnings. Although warning messages do not prevent the analyst from continuing, it is very important that these messages are reviewed to decide whether an action is warranted. How do we run a model variation? On the Models Load tab, click Validate, which is the checkmark validate checks that have been performed if any existing display with warning messages. How to control the conditions conserved during the model validation? Click over the model settings, and on the validation page, check for the validation conditions to be considered. Edit commands. The other toolbar provides copy to move of the mirror and rotate model or part of it. It also has commands splitting, joining, deleting, and reversing directions of the member. The edit toolbar contains the following: the button and the description. The copy makes existing selected objects to a new location in the model. Copy loads existing selected loads to a new location between load cases. Move existing selected objects to a new location in the model. Mirror reflected copy existing selected objects about a given plane. Delete. The command is either delete items. Join members to a longer continuous member. Split existing continuous members. Reverse. In front and back faces of the wind wall panel. The front of each wall should be facing outwards in order to correctly determine the wind direction relative to the wall. Also, reverse local x-axis of the beam that can be useful for standardizing output. Beam lines. Joining existing concrete beams to make a continuous concrete beam. Cutting planes. Useful tools temporarily hidden parts of the model obscure the area with which you are required to work on. By dragging cutting planes over the slices through the model, everything in its on the positive side of the plane has hidden, leaving only items on the negative side still visible. See cutting planes. Move model. Move the entire model to a new origin. Rationalize. Opening a dialog which allows you to remove the unused slope panes and frames. Remove the unused grid lines. Remove the unused construction lines. Update all grid construction lines extended with exactly 1 foot 8 inches beyond the point where they are required. See rationalizing the model. Move the DXF shadow. Move the DXF shadow to a new origin. Create infills. Creates a pattern infill members in the selected bay. Related target command of ribbon tools. Copy and move of the mirrored objects. Copy move of the mirror editing commands only because active they have then selected selected objects you want to edit. Here do I copy elements to new location to copy the existing elements to a new location, select the members to be edited, click edit copy. Alternatively, you can select copy from the right click context menu. If the copy element dialog box, you can in the copy elements dialog, you can either choose to clear the elements set to be complete copied, if so required, or leave the element selected in order to copy the entire selection. Pick the reference node in the property window. Select keep elevation if you want to copy the selected element horizontally. Ignore any difference of the elevation between the reference node and the new position. Alternatively, keep the elevation if you want to copy the elements to move both vertically and horizontally. 6. Pick the new position to move the members. 7. Select the members or copy to the new location. How do we copy to rotate elements in the new location? Copy to rotate existing elements to a new location in the model. Select the members to be copied. Select edit and copy. Alternatively, you can select copy with the right click context menu in the copy element dialog box. You either choose to clear the element set to be copied, if so required, leave all elements selected in order to copy the entire selection. Property windows with the rotation required about the Z-axis. Pick Pick the reference node and property node windows. Keep the elevation if you want to copy the selected element horizontally. Ignore the difference elevation between the reference node and the new position. Alternatively, keep the elevation if you want to copy the elements to move both vertically and horizontally. Pick the new position and move the members to. The selected members are copied to the new location rotated. How do I move elements to the new location? Many elements to the new location. Smile, select the members to move, edit, and move, and click edit to the move. Pick the reference node, pick the new position, move the members to, then select the member to move to the new location. How do I move rotate elements to a new location? To move them, rotate elements to a new location in the model, select the members to move, click edit and move. In the property windows, enter the rotation required about the z-axis, pick the reference node, pick the new position and move the members, select the members or move them rotated to the new location. How do I mirror elements to the new location? Copy existing elements of mirroring about the specified plane, select the members to be mirrored, click edit, mirror the property windows, select them in the mirror mode along the Y mirrors along the global X and Z plane defined by the single reference node, and show the alphanumeric mirroring of graded lines and your mirror line, which is pick reference enters and X and Y values. Along X mirrors the global YZ plane defined the single reference node, and show the alphanumeric situation interferes X and Y nodes, and then show the different mirroring line. Picking a mirror line, show the Y and X axis. Pick a mirror about the Z plane defined with the two reference node. So now we have a alphanumeric grid line, mirror line, selected selected mirror plane point, selected second mirror plane point. Pick destination point mirrors for the Z plane perpendicular to reference nodes. And then we can do and pick a new position, pick the reference node, and show that the selected members are mirrored with the selected plane. Copy loads commands can be either copy member panel structural load with different locations, can also be either copy loads between load cases. How do I copy all the member loads with one span to another? Click edit copy load with the property window with the copy span loading mode. Property window choose either the copy load with the current load case, all the load case of the current load cases. You must also select the required load case with the loading drop down list to select loaded the element span prompt is displayed. For click a span containing the members loaded to be copied and applied loading onto spans prompt is displayed. Click a span that if you want to apply the loads to. The member loads are copied to the chosen span. Source span, the destination span does not need to be the same length. Click additional spans required to continue applying loads. Press escape in order to select a different load element span to copy from, and then press escape twice to execute the command. How do I copy just one member load, and if several are applied to the same span? Click edit, copy loads, property windows, copy the members area load mode. Select load to be copied property is displayed. Click the member loaded to be copied to apply a load, copy the property is displayed. Click the span one and apply with the load 2 with the member load is copied with the chosen span. Source of the span, the destination of the span does not need to be the same length. Click additional spans required to the copy the applying load. Press escape in order to select the different load. Copy press escape twice to execute the command. How do I copy the panel arrow level and slab loads? Click edit with the copied load. Select the required load case. Option to loading drop down list. Property window. Select the copied member area load mode. Select load to be copied to prompt and is displayed. Click the area slab level load to be copied and apply load copy to prompt is displayed. Click the panel in which the load is to be applied. Click the load is applied. The copy load is applied. Click additional panels required with continuing applying the load. Press escape in order to select different load to copy. Press escape twice to exit the command. How do I copy the panel, point, line, or patch loads? Click edit, copy the load. Select the required load case for the load drop down list. Property windows, copy plane loads mode. Select the load to be copied. Property display. Click the panel, point, line, patch load to be copied. At this point, you can add selection required clicking additional loads. After you can also remove the load for the selecting, clicking it once more. Red circle to display with the original reference point of the selected load to apply the loads. Either click on the panel with the node to define with a new reference with the point with the node. The loads are applied with the same offset with a new reference point. Click anywhere within the plane panel boundary at a different level to define with a new reference point directly above the original reference point with the loads are applied with the same offset with a new reference point. If you achieve a new reference point with the result of the loads being applied with the outside of the panel or will not be applied with the panel with the situation of the warning will be issued during validation. Click with the required with the defined further reference point with the continuing applying the loads. Press escape in order to select the different loads. Copy the exit twice to exit the command. How do I copy the structure loads? Click edit, copy loads, property windows, copy member area load mode. Select the loads to be copied, property displayed. Click the structural load to be copied, apply the load, copy the property that's displayed. Click where you want to apply the load to the structural load copied with the new location. Click an additional location locations required with the copy deploying load. Press escape in order to select a different load to copy, or press escape twice to activate the command. How do I copy loads to another load case? Click edit, copy to load, select the load case to be copied to load, drop down list, property windows, copy to loads to another load case mode, property windows, select the load case, copy to loads to, select load to copy the property, the display of the loads to be copied. At this point, you add the selection required with the click on the additional loads. You can also remove the load with the selection by clicking it once more. Press to copy the load with the load case display with the property windows. Press enter with the press escape at the end of it. Order to select a different load to copy and press escape twice to exit the command. Joining and splitting members. Joining and split commands are either to join discontinuous members and splitting with the continuous members of any material. How do I join command members made continuous? Provided the angle between the two similar members is less than 45 degrees in both plan and elevation. You are able to do you're able to join them with make a long or continuous member. A join command can be used to manually join concrete beams, even with the allow manually can join concrete beams, even when allow automatic join beam property is clear. This because the property only apply with the automatic join that occurs during the design process when the beam lines command is run. Click edit join. However, the cursor member that is to be joined or with another member, both original member that will be joined become highlighted at the point will be joined, indicated with a red dot, with the wrong end of it being joined with a move of the cursor toward the other end of the member until the correct end is indicated. The join beams must have the endpoints in common. The beam fails to join, and they probably have been used different grade construction lines at the endpoint question. Click highlighted members join, and then pick additional members as joins that are to join as required. Press escape when complete. How do I split a member? Members have previously joined can be split if required. Click edit split. The members of the cursor previously joined members that you want to split. The members highlighted the point which the split is indicated with a red dot. Only with the members validating splitting highlighted when you hover over the cursor over them. For clicking the members to split with the point indicated with the move of the cursor further along with the member, identify with the points which can be split with the member being split is a concrete beam and a split with the two separate beams, with the first one having the all-out automatic join N2 with the beam property clear, with the second one having the automatic join N1 beam property is clear. That prevents the two beams of being automatically made continuous once again when the model is designed. Concrete beam lines. Concrete beam lines are formed automatically as part of the combined analysis design process. However, it would prefer to greater control of the tube of the beam lines command manually. In this way, the verify the continuous beam lines are formed with intent of the beam before proceeding with the design. When running manual beam lines command, apply with all concrete beam members in model within irrespectively or whether they're selected or not. Discontinuous concrete beams can only be joined with the all-out if the allow automatic join beam property is checked with the appropriate beam ends is joined. The ends will only be joined when the following criteria are met. The angle in which the plan in which two joins meet is less than the limiting joining angle in the plan specified the model settings beam lines, and the angle of elevation in which the two beams is less than limited joining angle elevation in the elevation specified model settings beam lines. The amount by which the cross-sectional area of the two beams overlap greater than the minimum section overlap percentage specified by the model settings of the beam lines. Additionally, either with the two beam ends with the join with a pin, they will not be joined with unless the join pin beam end box checked with the model setting beam lines. How do I automatically join all concrete beams? Make continuous. Click edit beam lines, reverse members, axis panel, surface panel faces. However, reverse the local axis of the beam. You can easily enter the beams run forward and backwards, consistently approach the habit, not adaptive during the model creation. By clicking and starting end over this, resolve the confusing force diagrams to be printed output. The reverse command can also be used manually standardized, flipping axis one beam one beam at a time. In this way, with the possible force all beams will run left, right, and bottom to top over the plane view. Reverse a beam, click edit, reverse. Click the beam and reverse its direction. How do I reverse outward face of the wind panel in front each of the wall facing outwards in order to correctly determine the wind direction relative to the wall? Check with the, in this case, ensure the outward forces are displayed with the color assigned with the wind wall front. If the wall is facing in the wrong direction, you should reverse it. Click edit and reverse. Click the wind wall panel to reverse its direction. Cutting planes. 6 cutting planes initially from the cubic to extend with each of the model. By activating a cutting plane, move it inwards and slide with the model. Everything to do in the positive side of the plane temporarily hidden from the view, with making it easier to work with in the area of the inside of the model. How do I activate or deactivate a cutting plane? Click edit cutting plane. Simply initiate editing plane. 6 initially deactivated cutting planes are shown. Click the plane and activate. The activating cutting plane faces are shown in a different color. By the default, blue indicates the positive side of the plane and red reverse side. To reactivate the cutting plane, click on the active plane to deactivate it. Click any part of the model where the previous heading from the view of the plane is redisplayed. How do I move the cutting plane in order to hide the part of the model? When cutting plane is after the large arrow project from the center of the arrow is used to reposition the plane to move the active cutting plane, click the arrow over the center of the plane. This arrow is replaced line indicating the direction in which the plane can move. Dragging the plane in the new position, press F2 to enter the exact distance. Cutting plane is redrawn in the new position. If the slices of the model, everything in the positive side of the plane is hidden from view. How do I reshow the hidden part of the model? Once the cutting plane has been positioned, no need to move it in order to reshow the hidden part of the model. All you need to do is deactivate the plane by clicking it once more. Moving the model or DXF shadow. Move model command is used to relocate entire model to the new coordinate in the X and Y plane. Similar to the move the DXF shadow command is to relocate the DXF shadow. This command only becomes available once the shadow has been imported. How do I move the model to a new location? In order to move the model to the first side of the reference point, to use reference point to determine the drawing of the imaginary box aligned with the X and Y around the extent of the model is shown below. So we have boundary corners, alphanumeric, and it's been changed to orientation bound centroid. Bound corners equates for the lower left-hand corner of the imaginary box. Bound centroid equates for the centroid of the imaginary box. Click Edit, Move Model, choose the reference point with the bound corners or bound centroid into the required target coordinate with the reference point. Click Move. How do I move the DXF shadow? Click Edit, Move the DXF shadow, choose the existing DXF shadow of the reference point. Click any other point, so for the new point, reference point, rationalizing the model. Rationalizing command provides efficient way of removing all unsloped planes, frames, grades, construction lines for the model. Additionally, can optionally update with all the grade construction lines to extend only a short length of 1 foot 8 inches beyond the point with required after running the summary change of the made list of the process window. How to remove the unused slope planes, frames, grid, and construction lines. Slope planes, frames, and grid construction lines are unused if they have no object. The lines are unused if they have no objects associated with them, provided that either can be removed in single operations files. Click Edit, Rationalize, select the checkboxes unused you want to remove. Plane removes unused slope planes, unused frames is also, and unused frames is also. Click OK. How do I update grid construction lines to extend only a short length beyond where they are required? Click Edit, Rationalize, Shrink, or Extend grid construction lines. Click OK. All grid construction lines are modeled updated with the extent of the fixed length of 1 foot 8 inches beyond the point where it is required. Creating infill members. Creating infill commands that you rapidly place the pattern of the infill members into the selected bay to level the slope plane and frame. Only those bay with members attached to all sides can be selected. How do I create infills? Define infill member properties and patterns. Click Edit and create infills. Select the bay, promptly appear with the bay and which fills in place. Those that have the members attached to all sides are identified by shading. Adjust the property window. Click Define beams and choose by number to specify the number of equally spaced members in the pattern, and by max spacing specify the spacing of the members in the pattern. Click the direction and choose perpendicular to have the members drawn perpendicular to the highlighted edge of the parallel with the left. Have the members drawn parallel to the edge member that connects to N1 highlighted edge member. Parallel to the right to have members drawn parallel to the edge member that connects to N.2 highlighted edge member. Define the element parameters as required. If you have saved the properties with the name property set, they can be recalled simply with selecting the set with the drop down list top of the property window. See how do I save the property name property set from the property window. To place the pattern in single bay with the half of the cursor over the required bay with the adjacent required edge member. The preview the infill pattern and apply with the highlighted edge member is displayed. Change the orientation, either the move of the cursor to the different edge member, or adjust the general parameters of the property windows. When both of the preview or element parameters are required, click within the bay to create the parent to place the pattern in multiple bays. A select bay prompt dialog box to select the required bays. The select reference bay prompt appears. However, the cursor over one of the selected bays adjacent to the required edge member. The preview of the infill pattern applied with a highlighted edge member is displayed. To change the orientation, either move the cursor to a different edge member or adjust general properties in the property windows. When both preview and element parameters are required, click within the bay to create the pattern selected bays. Loading guide. We're going to cut the tape there.